All right, welcome back to the deep dive.
Ready for takeoff.
This time, we're strapping in
Yeah.
and getting ready for takeoff with a deep dive into the world of flying.
Nice.
And we're not just talking about boarding a plane. No.
Nope.
We're tackling
The how-to.
the help-tos of actually piloting a plane.
Nice. I like this.
So I am excited to delve into these manuals, diagrams,
Oh, yeah.
and historical tidbits we've got stacked up here.
Well, what I find fascinating is the sheer complexity of flight.
Oh, yeah.
It's not just knowing, which lever pulls up and which one pushes down.
Right.
It's a delicate dance of physics, engineering, and human skill.
For sure.
We're going to unpack all of that, from those core concepts and forces at play to even the psychological elements of piloting.
And get this, one of our sources lays out the 7 steps to actually becoming a pilot.
Ooh.
I've always been fascinated by the idea of flying.
Yeah.
It just seems almost magical, being able to lift something heavier than air and soar through the sky.
It's pretty mind-blowing when you think about it.
Yeah.
One of our sources digs into how we achieve this seemingly impossible feat.
Okay.
And it all boils down to lift. Lift is that force that counteracts gravity and allows a plane to stay aloft.
Yeah, I always pictured it like the wing is cleverly catching the air,
Yes.
using that pressure difference to its advantage.
That's a great visualization.
Right.
And then we have some called thrust component lift, generated by the angle of the engine as it propels the aircraft forward.
Oh.
It's a more subtle upward push,
Okay.
working in conjunction with the wings.
So it's this dynamic interplay between the wings and the engine
Yeah,
that creates enough lift to overcome gravity.
exactly.
Makes you wonder how those early aviation pioneers even dared to believe flight was possible.
It is incredible to think about those early days, right? I mean,
Yeah.
hot air balloons, those made sense.
Right. Lighter than air.
Lighter than air, yeah, using buoyancy to float. But a heavier than air machine, that must have seemed like pure fantasy.
Right. Talk about pushing the boundaries of what seemed possible.
Totally.
And speaking of pushing boundaries,
Okay.
one of our sources highlighted something I never really considered before.
Okay.
How much drag those wheels create.
Oh, interesting.
Yeah, by folding them up after takeoff.
Oh, right.
The reduction in air resistance is significant.
It really underscores how crucial streamlining is in aircraft design.
Yeah.
Every little bump, curve,
Oh, wow.
even the material the plane is made of impacts how smoothly the air flows around it.
It's like trying to swim through water versus honey.
Exactly.
You want the air to flow over the plane as smoothly as possible.
Yeah.
And that makes me think of those stealth bombers.
Oh, cool.
Their unique shapes and materials are designed to minimize their radar signature,
Right.
making them harder to detect.
That's a perfect example of how deeply engineers have to understand aerodynamics
Yeah.
to achieve specific flight goals.
To get what they want. And speaking of crucial aerodynamic concepts, let's talk about angle of attack.
Okay.
This one seems to be a core principle for aspiring pilots to understand.
Yes, the angle of attack is essentially the angle between the wing and the oncoming air.
Okay.
Picture it like this. The wing is tilted slightly upwards as it moves through the air.
Okay, so it's how tilted the wing is.
Yes.
But why is that angle so important?
Well, changing the angle of attack directly affects how much lift is generated.
Gotcha.
If the angle is too steep, the airflow gets disrupted.
Oh.
And that can lead to a stall, which is definitely something you want to avoid.
So there's an ideal sweet spot for that angle.
Exactly.
Balancing lift with stable airflow.
Yeah, and this makes me think of one line from our research.
Okay.
Engineers designed your airplane to be aerodynamic, and manufacturers built it to fly. If started and turned loose, it could fly by itself.
That's a fascinating point.
It is.
It brings up the question of the pilot's role.
Right.
If a plane is inherently designed to fly,
Yeah.
what does the pilot actually do?
That's where the human element comes in.
Mm.
And it's more complex than it might seem at first.
Okay.
While a well-designed aircraft does have a certain level of inherent stability,
Right.
the pilot is vital.
Hmm.
They are the ones guiding the plane, making decisions, reacting to changing conditions,
Right.
and handling any unforeseen situations.
So it's less about forcing the plane to fly
Yes.
and more about understanding its tendencies
Exactly.
and working with those tendencies to achieve a desired flight path.
Yeah, it's almost like a partnership between the plane and the pilot.
Exactly. And speaking of partnerships,
Okay.
let's talk about the journey to actually becoming a pilot.
Right.
One of our sources outlined the 7 steps involved,
Okay.
and it all starts with finding the right flight school.
Yes.
And most importantly, a great instructor.
That's key.
They'll be your guide through this whole process.
Absolutely.
And then there's that medical certificate, right?
Yeah.
Making sure you're fit to fly.
Right.
I'm imagining it's pretty intense.
Yeah. It depends on what type of pilot certificate you're aiming for.
Oh, okay.
There are different levels, like sport pilot and private pilot, each with its own set of requirements.
So that's really interesting. So there are different paths to becoming a pilot,
Yeah.
each with its own level of complexity and rigor.
For sure.
Can we dive a little deeper into those different pilot certifications later?
Absolutely. We can definitely do that.
But for now, let's stick with those 7 steps.
Okay.
What comes after the medical certificate?
Well, that's when the real learning begins.
Okay.
You've got ground school to grasp the theoretical side of aviation,
Right.
then flight training where you actually get in the cockpit and put those theories into practice.
Oh, wow.
You'll work your way up to solo flights,
Wow.
which must be an incredible feeling.
Oh, yeah.
And finally, you'll take a practical test to get your license.
Okay, so it's a blend of book smarts from ground school
Yes.
and hands-on experience in the air.
Yeah, exactly.
It's fascinating to see how this process builds upon itself, step by step,
Yeah.
from those initial dreams of flight to actually taking the controls.
It's quite a journey.
And speaking of taking the controls,
Okay.
what really stood out to me in these sources was the emphasis on emergency procedures.
Oh, yeah, for sure.
You know, those what-if scenarios that every pilot needs to be prepared for.
Absolutely. Being prepared for those unexpected situations is crucial.
I have to admit, the one that always gets to me
Oh, yeah.
is the thought of an engine failure mid-flight.
Sure.
What happens then?
Well, one of our sources breaks down that exact scenario.
Okay.
If the engine fails,
Right.
pilots are trained to find a safe landing spot
Okay.
and execute an engine-out landing procedure.
Okay.
It's all about staying calm, assessing the situation,
Right.
and following the right steps.
That sounds terrifying, but also incredibly empowering.
Yes.
To know that there are procedures in place to handle even those most stressful situations.
Yeah. It definitely highlights the importance of not just knowing how to fly,
Right.
but knowing how to react when things don't go as planned.
Right. It seems like a crucial part of being a pilot is having the mental fortitude
Yes.
to stay calm and make the best decisions.
Exact.
Even when facing unexpected challenges.
Exactly. It's about more than just stick and rudder skills.
Right.
It's about developing a pilot's mindset.
Well, on that note,
Right.
let's pick up right here in the next part of our deep dive
Sounds great.
into the world of flight.
I can't wait. You know, before the break, we were talking about emergency procedures, and that got me thinking about some of the other potentially tricky situations
Oh, yeah.
pilots might encounter.
Right.
One that comes to mind is stalling.
Oh, yeah.
It seems counterintuitive
Wait
to
a minute.
intentionally practice something that you want to avoid at all costs.
You're right. Stalling is something we definitely want to avoid.
Yeah.
But understanding how and why it happens
It's
is
tough.
crucial for any pilot. And practicing stall recovery techniques in a safe environment
Right.
is a vital part of training.
Absolutely.
So help me understand this.
Okay.
What exactly happens when a plane stalls?
Essentially, a stall occurs when the wing exceeds its critical angle of attack.
Yeah.
Remember we discussed how that angle between the wing and the oncoming airflow
Right.
affects lift?
Yeah. If the angle's too steep, the
Yeah.
airflow gets disrupted
Yeah,
and the wing loses lift.
that's exactly it.
Okay.
During a stall, that smooth airflow over the wing, what's called laminar flow, breaks down and becomes turbulent, causing a sudden drop in lift.
So to put it simply, the plane essentially stops flying.
In a way, yes.
Okay.
It loses its ability to maintain altitude and begins to descend.
That sounds pretty terrifying.
It can be a bit unsettling, but with the proper training,
Yeah.
pilots can recognize the warning signs of an impending stall
Okay.
and take action to recover.
What kind of warning signs should a pilot be looking out for?
There are a few key indicators. First, you'll notice a decrease in airspeed as the aircraft gets closer to stalling.
Gotcha.
The controls will also start to feel sluggish and less responsive.
So the plane doesn't react as quickly to your inputs, almost like it's becoming heavier?
That's a good way to describe it.
Okay.
You might also hear a stall warning horn, or you might feel the aircraft buffeting or vibrating as that airflow becomes turbulent.
Okay, so those are the signs. What actions should a pilot take if they find themselves in a stall?
The key is to break the stall quickly and smoothly.
Okay.
The standard procedure involves reducing the angle of attack, adding power, and leveling the wings all at the same time.
So basically push the nose down to get that smooth airflow back over the wings, give it more throttle to increase lift.
Yeah.
And make sure the plane isn't turning.
You got it.
Okay.
It sounds straightforward, but it requires quick thinking and coordinated control inputs.
Right.
The faster you recognize the stall and react, the less altitude you'll lose.
It really underscores how vital practice is.
Ooh.
If you're already familiar with the procedures
Yeah.
and have that muscle memory built up,
Right.
you're more likely to react effectively in a real situation.
Absolutely. That's why practicing stalls at a safe altitude with a qualified instructor is so crucial. It builds confidence and helps you develop those instinctive reactions.
So with the right training, stalls are a recoverable situation.
Yeah.
What about something like an engine failure?
Right.
That seems like a much more dire problem.
You're right. Engine failure is a serious issue. But again, proper training and preparation can equip a pilot to handle it safely.
What's the first thing a pilot should do if the engine cuts out mid-flight?
One of our sources outlines the steps for an engine outlanding procedure.
Okay.
The immediate priority is to establish the best glide speed, which is the airspeed that will give you the most distance possible
Right.
while minimizing altitude loss.
So you're essentially trying to turn the plane into a glider and find a place to land.
Exactly. It's all about maximizing your time and distance to make a safe landing.
Okay, you find that ideal glide speed. What's next?
The next step is to find a suitable landing area.
Right.
Ideally, you want a long, flat, clear surface,
Like a runway.
like a runway or a large field.
Right, but in an emergency, you might have to work with whatever options are available.
Right, exactly.
I can only imagine those picture-perfect emergency landings you sometimes see in movies
Yeah.
are probably pretty rare in real life.
Right, not every situation is going to present a convenient runway.
What if you're flying over mountainous terrain or a densely populated area?
That's when things get really challenging.
Yeah.
Pilots need to be able to assess the situation quickly,
Right.
consider all the options,
Yeah.
and make the best possible decision
Right.
given the circumstances.
It must take incredible composure and quick thinking to process all of that under pressure.
It does, and that's why pilots train for these kinds of scenarios, learning how to analyze risks,
Right.
manage stress,
Right.
and effectively execute those emergency procedures.
So finding that landing spot is priority number one.
Yes.
What else is important during an engine out landing?
You'll want to go through your emergency checklist.
Okay.
Try to restart the engine if possible.
Right.
And you absolutely need to communicate with air traffic control, letting them know what's happening and what your intentions are.
Clear communication is key in any emergency.
Absolutely.
It allows for coordination and ensures everyone's on the same page.
And as you approach your chosen landing area, you need to carefully manage your airspeed and altitude
Right.
to make sure you touch down smoothly and in control.
It sounds like a real balancing act,
Yeah.
requiring precision and a deep understanding of how the plane will behave.
It is. It really speaks to the level of skill and training pilots go through to handle these high-pressure situations calmly and professionally.
It's becoming clear that flying is as much about mental preparedness as it is about physical skill.
Absolutely.
Having the right mindset seems essential to deal with whatever comes your way.
You're absolutely right.
Okay.
Staying calm, focused, and resourceful even when things go wrong is a huge part of being a pilot.
And speaking of resourcefulness, one thing that caught my eye in the research was the concept of off-field landings.
Oh, yeah. Off-field landings.
You know, landings made on surfaces that aren't a designated runway.
Those can be necessary in emergencies or for pilots who enjoy backcountry flying.
Right.
They definitely require a different set of skills and considerations.
What are some of the things a pilot needs to keep in mind when attempting an off-field landing?
First and foremost, you need to carefully assess the landing area.
Okay.
You're looking for any potential hazards, obstacles, uneven terrain, soft surfaces,
Right.
anything that could pose a risk.
I imagine that's much harder to do when you're not dealing with a clearly marked runway.
Absolutely.
Right.
You have to be extra vigilant and really pay attention to your surroundings.
Yeah.
You need to be able to judge distances and slopes accurately.
So good judgment and visual perception become even more critical in those situations.
Exactly.
Okay.
You also need to be very aware of wind conditions,
Right.
which can significantly impact your approach and landing.
Wind can be tricky even on a runway.
Right.
I can only imagine how much more challenging it is when landing in an uncontrolled environment.
It definitely adds another layer of complexity.
Right.
You might need to adjust your approach angle, airspeed,
Yeah.
or even the direction you're landing in to compensate for the wind.
So off-field landings require adaptability and improvisation.
Yeah.
You can't just rely on a fixed set of procedures.
Right.
You have to adjust to the conditions as you find them.
That's a great way to put it.
Thanks.
It's one of the things that makes off-field landing so challenging, but also so rewarding for pilots who enjoy that kind of flying.
Well, speaking of challenging and rewarding, let's shift gears a bit.
Okay.
And talk about something that's often seen as one of the most thrilling aspects of flying.
Okay.
Aerobatics.
Aerobatics.
Yeah. The art of performing maneuvers that seem to defy gravity.
Right.
Pushing the limits of both the aircraft and the pilot.
It's pretty amazing.
I've always been fascinated by aerobatics.
Yeah.
But I have to admit, it seems a bit intimidating.
Sure.
What are some of the basic maneuvers involved?
There's a whole collection of aerobatic maneuvers.
Oh, wow.
Each with its own unique set of challenges and thrills.
Right.
Some of the classics include loops, rolls, spins, and hammerheads.
I've heard of those.
Yeah.
But can you break them down for me? What exactly does a loop entail?
A loop is basically a 360-degree vertical circle.
Okay.
The plane starts in level flight, climbs straight up,
Right.
inverts at the top of the loop, and then descends back down to level flight.
Wow, it sounds like riding a roller coaster in the sky.
It is quite the experience.
Yeah.
It requires very precise control inputs and a good understanding of how the aircraft will react under G-forces.
G-forces, what are those exactly?
G-forces are the forces you feel during acceleration, deceleration,
Right.
or changes in direction. They're measured in multiples of the force of gravity, which is 1G.
So if you're experiencing 2 Gs, it feels like you weigh twice as much.
Exactly.
Oh.
And during aerobatic maneuvers, pilots experience both positive and negative G-forces,
Right.
which can put stress on the body and require specific techniques for managing those forces.
So aerobatics is not for the faint of heart.
No, it's definitely physically and mentally demanding.
Right.
But for those who are drawn to the challenge,
Yeah.
the thrill of pushing those boundaries,
Right.
it can be incredibly rewarding.
What about rolls?
Okay.
What do those look like?
A roll is a maneuver where the aircraft rotates 360 degrees around its longitudinal axis.
Okay.
Imagine the plane spinning like a corkscrew.
So it's like a horizontal spin.
You could describe it that way.
Okay.
There are different types of rolls, like aileron rolls, barrel rolls, and slow rolls, each with its own unique characteristics.
And what about spins?
Okay.
Those sound a bit scary.
A spin is a maneuver where the aircraft descends rapidly
Oh.
while rotating around its vertical axis.
Oh,
It can be intentional or unintentional,
Right.
and it can be quite disorienting.
So it's like a controlled downward spiral?
In a way, yes.
Okay.
But it's a more complex aerodynamic phenomenon.
Okay.
It involves the aircraft stalling and entering this rotating descent.
And hammerheads, what are those all about?
A hammerhead is a maneuver where the aircraft climbs vertically,
Okay.
pauses momentarily at the top of the climb,
Hmm.
and then pivots 180 degrees before diving straight down.
So it's almost like the plane is doing a handstand in the sky.
That's a great way to visualize it.
Okay.
It's a visually impressive maneuver,
Right.
but one that requires a lot of skill and precision to execute safely.
Aerobatics really is a whole world unto itself.
It is.
It's incredible what skilled pilots can do with an aircraft,
Yeah.
pushing the limits of what's possible.
It's a testament to human skill,
Yeah.
ingenuity, and that desire to push the boundaries of flight.
This deep dive is giving me a whole new appreciation for the complexity and diversity of flight.
Oh, yeah.
From those basic principles
Yeah.
to these advanced aerobatic maneuvers.
And we've only just scratched the surface.
Oh, really?
There's a whole universe of knowledge and experience to delve into when it comes to aviation.
Well, on that note, let's take a short break.
Okay.
When we return, we'll continue our exploration of the fascinating world of flight,
Sounds good.
from its historical roots to the cutting-edge technologies shaping its future.
Awesome. Looking forward to it.
We're back for the final leg of our deep dive into the world of flight.
Nice.
Before the break, we were talking about those amazing feats of aerobatics,
Yeah,
which really highlights the level of skill and precision involved in piloting.
absolutely.
It makes you realize that there's a whole history behind how we got to this point.
You're absolutely right.
Yeah.
It's incredible to look back and see how far aviation has come
Yeah.
since those early days of experimentation and daring.
One of our sources touches on some of those historical milestones.
Oh, cool.
And the pioneering figures who really shaped the field.
Right.
It's a fascinating read.
Well, when we're talking about aviation pioneers, we have to start with the Wright brothers,
Oh, of course.
Wilbur and Orville.
Yeah.
They made history with the first successful, sustained flight of a heavier-than-air aircraft back in 1903.
The Wright Flyer.
Yes.
I remember seeing pictures of it in textbooks.
Oh, yeah.
It's such a simple-looking machine compared to modern aircraft.
Right.
It's amazing to think that was the catalyst.
It really was.
For everything that came after.
Their ingenuity and persistence really did pave the way for all the advancements in aviation we see today.
For sure.
They turned what was once considered impossible into a reality.
And speaking of paving the way, another figure who stands out is Amelia Earhart.
Oh, absolutely.
She became an international icon for her daring flights and her advocacy for women in aviation.
Amelia Earhart, yeah.
Her solo flight across the Atlantic Ocean in 1932 was a monumental achievement.
She was a true trailblazer.
Yeah.
Pushing the boundaries of what was considered possible for women in her time.
Her courage and her spirit of adventure continue to inspire people even today.
Absolutely.
Proving that with determination, anything is achievable.
It's truly remarkable to see how those early pioneers not only pushed the boundaries of flight, but also challenged societal norms and broadened our horizons of what's possible for humankind.
Their stories are a testament to the power of human curiosity.
Yeah.
And our innate desire to explore and push beyond perceived limitations.
And that spirit of exploration continues to drive aviation today.
Yes.
With emerging trends and technologies constantly reshaping the landscape of flight.
You're right.
Yeah.
Our sources delve into some of those exciting new developments.
Okay.
Like electric aircraft and autonomous flight systems.
It feels like we're on the cusp of a whole new era of aviation.
I think so too. Electric aircraft especially seem to be gaining momentum.
They are.
What are some of the advantages they offer over traditional aircraft?
One of the biggest advantages is reduced noise and emissions.
Okay.
Electric motors are significantly quieter.
Right.
And don't produce the same harmful pollutants as combustion engines, making them a much more environmentally friendly option.
That's a huge plus, considering growing concerns about climate change and the impact of aviation on the environment.
Exactly. And electric aircraft can also be more efficient in terms of energy consumption.
Oh, okay.
Electric motors convert energy into motion more effectively.
Right.
Which can potentially lead to lower operating costs.
So it's a win-win
for
both the environment and for airlines looking to reduce expenses.
That's the idea.
But of course, there are still some challenges to overcome before electric aircraft become the norm.
Right, there are.
What are some of the main hurdles in the development of electric-powered flight?
One of the primary challenges is battery technology. Electric aircraft require batteries that are lightweight, powerful, and capable of providing a long range.
Right.
While battery technology has made great strides, it still has a ways to go to meet the demands of long-haul flights.
So for now, range is still a limiting factor for electric aircraft.
Yes, for the moment.
Yeah.
But research and development in battery technology are ongoing.
Right.
And we can expect to see significant improvements in the coming years.
Yeah.
It's an exciting field to watch.
Absolutely.
Yeah.
Now, what about those autonomous flight systems?
Okay.
How are those shaping the future of aviation?
Autonomous flight systems, or self-flying aircraft as they're sometimes called, are basically aircraft that can operate without a human pilot. They rely on sensors, artificial intelligence, and complex algorithms to navigate, control the aircraft, and make decisions during flight.
So it's like having a computer in the cockpit making all the decisions.
You could say that. And while fully autonomous passenger aircraft are still some years away, autonomous systems are already being used for cargo transport, aerial surveillance, and other applications.
What are some of the potential benefits of incorporating autonomous systems into aviation?
One of the most significant benefits is increased safety.
Okay.
Autonomous systems are not prone to human error,
Right.
fatigue, or distraction.
Yeah.
Which makes them potentially safer than human pilots in certain situations.
Makes sense. If you eliminate the human factor,
Right.
you eliminate a lot of the potential for mistakes.
That's the thinking.
Okay.
They can also be more efficient.
Right.
Autonomous systems can optimize flight paths, reduce fuel consumption,
Okay.
and operate more predictably, leading to cost savings and increased efficiency.
So they could potentially make flying cheaper, faster, and even more environmentally friendly.
Exactly.
And they could also open up new possibilities in aviation,
Right.
allowing us to access remote areas.
Yeah.
Perform tasks that are too dangerous for humans. Right. And even explore other planets autonomously.
It's really quite remarkable.
The possibilities seem endless.
They do.
It sounds like autonomous systems have the potential to revolutionize the way we think about and interact with flight.
Absolutely. It's an exciting time to be following the developments in this field.
Yeah, who knows what the future holds for aviation.
It's a good reminder that we're still in the early stages of flight, really.
Yeah.
There's so much more to discover and explore.
Well, before we wrap up our deep dives today,
okay,
there's one more topic I'd like to touch on.
Okay.
It's something that was mentioned in several of our sources.
All right.
And it really resonates with me.
Oh, cool.
It's that sense of wonder and freedom that flight can inspire.
Ah, yes, those intangible rewards that draw people to aviation.
Yeah.
And keep them coming back for more.
What is it about flying that evokes such a sense of wonder and freedom?
There's something truly magical about breaking free from the ground.
Yeah.
And soaring above the earth. Seeing the world from a completely different perspective.
Yeah, you're right.
It's a feeling of liberation, a sense of transcending limits and embracing the boundless possibilities of the sky.
It's like you're stepping outside the confines of everyday life.
Yeah.
And entering a whole new realm of experience.
Exactly. And there's a beauty and serenity to flight.
Yeah.
That's hard to capture in words.
I can imagine.
The smooth motion of the aircraft, the vastness of the sky, the ever-changing scenery below, it's simply awe-inspiring.
It sounds like a truly transformative experience.
It is.
One that can shift your perspective and leave a lasting impression.
Flying also offers a unique sense of perspective.
Yeah.
A chance to see the world from a different angle. To appreciate the interconnectedness of things.
Right.
And to realize just how small and insignificant our everyday worries and concerns can seem when viewed from above.
It's like you're getting a glimpse of the bigger picture.
Yeah.
A reminder that there's more to life than the things that tend to dominate our attention on the ground.
Precisely. That shift in perspective can be incredibly humbling and inspiring.
For sure.
It can prompt us to reassess our priorities, appreciate the beauty and fragility of our planet, and cultivate a sense of wonder and gratitude for the gift of flight.
It sounds like flying isn't just about getting from point A to point B.
Right.
It's a journey of self-discovery and a chance to connect with something larger than ourselves.
I think that's a beautiful way to put it.
Thanks.
It's about embracing the wonder, the freedom, and the transformative power of flight.
Well, this deep dive has certainly captured that sense of wonder and possibility.
Yeah.
It's been an incredible journey.
It has.
Exploring the many facets of aviation, from its history and technology to the human element and the profound impact flight can have on our perspectives.
It's been a pleasure sharing this exploration with you and our listeners.
For all you learners out there, we hope this deep dive has sparked your curiosity and ignited a passion for the skies.
Perhaps it's even inspired some of you to take that first step towards earning your wings.
Yeah.
Who knows, maybe one day you'll be sharing your own flying experiences with us.
That would be awesome.
Yeah.
Until then, keep your eyes on the horizon and never stop exploring the boundless possibilities of flight.
And remember, adventure is out there waiting to be discovered.
Oh, yeah.
Whether it's in the cockpit of an airplane or in the pursuit of your own personal dreams.
Thanks for joining us on the Deep Dive.
It's been fun.
We'll see you next time, ready to explore another fascinating topic in depth.
See ya.